Hello and welcome to our discussion on acid-base indicators. When we titrate, we have to have some way to know either qualitatively or quantitatively what's happening in our solution, because you certainly aren't seeing visibly exactly what's happening with the molecules of acids and bases, or whatever types of molecules you might be titrating. So we're going to talk about chemical indicators of different colors and types, and help you make good decisions about choosing an indicator for a titration. So indicators change color at a certain pH, and we call that pH for each individual indicator the endpoint. And endpoint is just when the indicator changes color. And so your goal is to have your endpoint, hopefully, where equivalence lies if you're doing an acid-base titration. And so these are just a bunch of different chemical compounds that change colors at certain pHs. You're probably familiar with things like phenolphthalein, here changing color between 8 and 10, or bromthiamyl blue, yellow from 6 to 8, yellow to blue, or perhaps some of the others. But there are benefits to taking each one depending on the specificity of your titration. So this is a strong acid, strong base titration curve, very sharp and pronounced. We want, if we're looking to see equivalence, we're looking to get endpoint and equivalence as close as possible. Okay? Since it's strong acid, strong base titration, you see the vertical slope is so large across the pH range, it really doesn't matter which indicator you choose as long as it sort of sits within this range somewhere. The volume difference between the phenolphthalein color change and the methyl red color change is minuscule. So you're pretty safe in choosing your color change there and choosing your indicator. For titrations involving weak acids or weak bases, we have to be a little bit more careful to look that to note that our equivalence is taking place near our endpoint. So choosing an indicator, about 10% of the initial form, chemical form of the indicator must be changed to whatever change the pH does to the solution before you'll see the new color visibly, grossly with your eyes. So the pH at which an indicator will change color is the indicator pKa, plus or minus 1. So you'd have to know the indicator's own pKa. They all have their own pKa. So you're looking for a pKa within 1 of your desired pH. So how to choose an indicator is the useful range of an indicator is usually it's pKa plus or minus 1. When choosing an indicator, determine the approximate pH, the equivalence point of the titration, and choose that indicator with a pKa plus or minus 1 of that value. So chemically, what is an indicator? They're weak acids, generally speaking, and we use the symbol HIN to indicate the intact acid, which would be the predominant form. They'll have one color in this form and then a different color in their basic form, or their conjugate basic form. Phenolphthalein, for example, is colorless in the intact acid configuration, but it is pink in its ion or conjugate base form. And so here we see that difference. pH 7, it's clear. pH 10, it's pink. And for grins, this is the chemical difference between the acidic form, with the hydrogen ion still attached, and then the pink form where we see the hydrogen ions have been lost to the system. And so those are the visible color changes, and then we can see the chemical difference too. Now, so like I said, in order for you to visibly see this change taking place, the acid form becoming the basic form, you would need 10% of these molecules to have lost hydrogen ions. So just real quick to talk about the choosing of the correct indicator. This is a weak acid, strong base titration, and we see that phenolphthalein would be a better choice than methyl red here, because you see that equivalence is taking place right in the phenolphthalein color change window. Well, if you'd chosen methyl red, you would see color change. You would still be somewhere between your acidic form and you would still be in acid form throughout your color change. You wouldn't actually be catching any of the equivalents at all with methyl red's color change. And so this is why it's important that you choose your pKa, your pH, so you choose your indicator based on your desired pH, in this case the equivalent of about 8.5, versus the pKa of your indicator. That is the last slide of the chemical indicators. We look forward to seeing you on the next one.